All right, y'all, let's get started. Thanks for coming out. I know you're hungry. This was just a 20-minute talk, and I think you're going to learn something, so I appreciate you coming out. I got to start with some introductions. This is per request, and this is BitBot. And our talk today is going to include some audience participation. There will be some trivia questions. So if you get the right answer to a trivia question, come down and see us at the booth. Take your pick of per request or BitBot. So a little bit about me. My name is Ben Boral, and I'm a solutions engineer at Bitrise. I got into mobile development about 10 years ago, got into Android about 5 years ago, got really into Kotlin, and I was the organizer of the Austin Kotlin meetup. That was pre-COVID, and we haven't really got our mojo back. But if you live in Austin, you're into Kotlin, talk to me. Maybe we'll get that going again. So I work at Bitrise. Bitrise is a continuous integration, continuous delivery platform. It's specifically for mobile. And so we got a bunch of great customers, including the ones you see on this slide. And today we're going to talk about Bitrise Build Cache. And that's a sort of a part of Bitrise related to speeding up your builds, because nobody likes waiting for PR builds. So, you know, it's instinctive to everybody in this room. We don't like long build durations, but if we could put some, real reasons on it, they are a tax on our satisfaction as developers. The people who pay us don't like us sitting around. They want us actually doing work. And when we're waiting for a slow build, we're just sitting around. And if your CI builds take a long time, you're kind of just burning money on infra. So there are some typical solutions to this. And anytime you come to an Android conference, you're going to hear some talks on, how do you tune your build graph? How do you modularize your app? And maybe some talks on a build cache. How do you set up a build cache and connect your build system to that? This talk is a little bit different. So we're going to talk about when you set up a build cache, how do you make sure it is the fastest? So quick background on what a build cache is to those who are new to this concept. What I'm telling you here is sort of Gradle, based on Gradle, but it applies to Bazel users or other build systems as well. And the particular implementation that we did at Bitrise also supports several build systems. So if we're looking at the top left, you're trying to generate an APK, and probably you've broken up your code base into a bunch of sub-projects. Each of those has a bunch of tasks. And so whenever you do a build, Gradle generates this task graph, and it executes thousands of tasks. And each of these tasks has a set of inputs, and a fingerprint is generated for those inputs, and then it generates the output. So we can save off that input fingerprint, and we can save the output, and then whenever we make some code change, and it only affects a tiny part of our project, and we rerun, we get to reuse the work that was already done in the past. So that build cache is where we store those input fingerprints and outputs. So I need to pause for a drink. All right, so whenever you have a build cache, the performance of that build cache is very tightly linked to the latency that you can get, or the latency involved with sending those task outputs, those cached outputs, back to wherever they're being used, whether that's the CI system that's doing a clean build or that's on the developer laptop. And if your build graph is really tall, then that latency is going to affect you even more. Because you can think about, you've got this task graph, and so there are a bunch of dependencies within that task graph. So if you're waiting for one thing, it's blocking everything downstream. And so then you're waiting for the next thing, it's blocking everything downstream. So there's this cascade effect. And so that's why latency is really important. There are three things that we've identified as bottlenecks that cause latency to become a problem. So the first is geographic distance. How far away is your build system from your build cache? Is your, let's say you live in Florida and most of your company's stuff is in California. So that's transcontinental, that's pretty far away. The next is how fast are the reads, right? So you're storing these task outputs, these cache entries in a persistent storage somewhere. How fast can you pull that and send it on the network? And then the third is the network protocol. So whenever you use a build cache, there's a very unique, or not unique, but there's a typical access pattern associated with that, and so we can apply the best network protocol to that access pattern. So if we look more in depth at geographic distance, okay, we have our first trivia question. And trivia question is, how fast do you think a network packet can be sent from one continent to another and back? And just throw out the answers. Who said 150? All right, bingo. So you're our winner. Come down to the Bitrise booth and you get your choice of plushie. So there you go, 150 milliseconds. And so what is the real world impact of that kind of latency? So we can actually see this in a case study that the Gradle team published. So I appreciate them publishing this because it's always good to have real world data. So a case study with the Cache app. And the Cache app developers use a build cache, and they host that in US West. And what they observed is that they have a typical time savings using a build cache of a little over 3 minutes for their West Coast-based developers. So those Android developers who are really close to that build cache. Okay, East Coast, there's like still a little benefit, but it's like starting to not be much. But what's really interesting is they're Australian developers. They had some the developers in Australia. And the builds were actually taking longer than if they just wouldn't use a build cache at all. So that geographic distance increases the network latency, and it actually causes you to have a harmful effect by using a build cache rather than like even a nil effect. So this like presents a very challenging problem. Where do you put your build cache? You want it to be fast for your CI builds. You want it to be fast for all of your developers, right? And if they're globally distributed, that seems like very impossible. So we came up with a solution. The solution is a CDN. So CDN is a content delivery network, global collection of edge nodes. These computers are in major metro areas all over the world, and they host replicas of the cache, the cache entries, so that the distance between developers and some cache storage is very small. And this is not something that most development organizations can do, right? So if you have a couple of hundred Android developers, it doesn't really make sense to pay all this money to set up this CDN network because that's super expensive for a small number of people getting the benefit. But Bitrise, we're doing this as a hosted service, so it's multi-tenant, and that brings network effects. So because everybody is using this CDN. It makes the cost for everybody come down, and it's actually feasible to have a CDN. In a little more detail, what are we doing? So we're putting our cache server, like our primary server, inside the data center. So again, like that distance affects latency, and we're minimizing that to the nth degree. That build server is just steps away from where your CI runner sits, right? So those CI builds are super fast. And then we've got the replica nodes. These are in a globally distributed CDN. And it means that there's probably, like if you're a developer, there's probably a CDN node in your metro area or in the nearest major metro area. So using those two things, we've reduced the distance between the users of the cache and where the cache lives. So next trivia, we already know 150 milliseconds between two continents. How long does it take to send a packet within the same data center? Any guesses? 10 milliseconds. 10 milliseconds, anybody else? 20 milliseconds. 20? 5? All right, well, I'll stop it there. 5 is closest. It's actually 0.5, so it's 300 times faster in the data center. So just, you can start to see how this stuff starts to add up. All right, so our next bottleneck is reading that information, right? Why does this matter? The way that the cache works is it has a ton of small entries, right? So the number of reads is quite high. A very simple Android app will easily have 1,000 task outputs. A non-trivial Android app is going to have an order of magnitude greater or more, I don't know. This also, for our Bazel users, Bazel also will have a large number of entries. So a couple of trivia questions. How long does it take to read a megabyte of data sequentially from an SSD and then from memory? Any guesses? 500 nanoseconds. All right, anybody else? 100 milliseconds? 1 millisecond? All right, we got a winner. 1 millisecond on the SSD. All right, and then on memory, 10 microseconds. So a lot faster, a couple of orders of magnitude. Okay, so you can start to see how we're finding these bottlenecks and we're eliminating them so that we can reduce latency. So what we're doing is we have in every cache node, we have what we call hot storage, so that's in-memory storage. And that contains a subset of the entries. And so for the most commonly used entries, those are going to live in the hot storage. And those are going to come out super fast. And then we also have high-performance SSD persistent storage for the other stuff that's not in memory. For somebody who has tried to set this up before, you might be saying like, well, this cannot be economical. Like, the amount of data to store in memory is just too high. You're gonna have to pay a ton of money. So we have some tricks up our sleeve. First of all, we use extremely efficient data compression at rest just to minimize the amount of data to store. And then we do something called content-defined chunking. And essentially what this is we say, we're going to dedupe the data based on its content. So you might have multiple builds, right? And for the same task, they might have different inputs that generate a different fingerprint, so that cache key, but actually the data itself is the same. And so we have something smart enough to say, oh, we can dedupe that, we only need to store one version of that. So that's how we're making this a lot more efficient to make it actually economic to store this stuff in memory. So our third bottleneck is the network protocol. And so I said before that the nature of using the build cache is a very large number of very small entries. And so, yeah, let me pull up that slide. You could just use like REST over HTTP 1.1, but we know that the access pattern is very high volume and it's small payload. So with HTTP 1.1, every time we do a request, we have to spin up a TCP connection, and that has an overhead. There's that handshake that you learned about in your like intro networking class that you forgot about. And so that really adds up whenever you do a high volume of network transactions. The other problem is that because these are very small transactions, the way TCP does congestion control, the number of packets it's going to send along at one time, it starts out slow and then it ramps up slowly. Well, because the transactions are small, it never really has enough time to even get up to sending a lot of packets at one time. This particularly affects the basal build system, which is super granular in the way it sends data. So our solution, we've implemented a custom Gradle plugin that uses gRPC streaming over HTTP2. And what that provides for us is a much smaller number of longer-lived TCP connections. So we get to reuse those, not have the overhead of all those handshakes. And then another side benefit is just there's better header compression, so that means we don't have to send as much data. So that's just quick summary, the 3 bottlenecks that we identified. And yeah, so geographic distance, it's speeding up that cache read, and it's using the right network protocol for the job. You'll notice I haven't provided you any like specific numbers. That's because it's very dependent on your build graph. Come talk to us at the booth. And we've sort of like soft launched a free tier. You don't have to be a Bitrise customer or anything. You don't have to do your CI in Bitrise, although it's better. But you can try it out and see like, okay, I just want to plug my build in to this build cache. What kind of effect is it going to have on my build times? Come talk to us. We'll get you access to that free tier, and you can give it a shot.